All right, guys. So you just learned what scientific notation was before spring break. So now you are going to learn how to multiply and divide scientific notations, basically. Okay. So we'll go over some things, go over a warm up, go over some activities, and then you'll have a chance to practice it. Okay. So this would have been your warm up if you were in class. Is each equation true or false for each of these? So there's three of them. And there's the answer is already there. So let's just talk about that. So 4 times 10 to the power of 5 times 4 to the power times 10 to the power of 4 is 4 times 10 to the power of 20. Okay? It is false because, yes, you're supposed to keep that number the same, but remember this rule? The power rule, I believe. The exponents were multiplied when they should have been added. So remember that was the very first rule we learned. So it should have been 5 plus 4, not 5 times 4. All right, let me see if I can do it for you guys. Yeah, there we go. Cool. Now this one, true or false? 7 times 10 to the power of 6 divided by 2 times 10 to the power of 4 equals 7 divided by 2 times 10 power of 6 minus 4. It's true because when dividing, the exponent in the denominator is subtracted from the numerator. Remember, when we're dividing exponents, we have to subtract the exponents. Okay? And then we go ahead and divide the other numbers as well. This one, take a look at this. 8.4 times 10 to the power of 3 times 2 equals, we put those into parentheses, times 10 to the power of 3 times 2. Yeah, definitely false. Multiplication can be done in any order, but the multiplication in this problem doesn't affect the power of 10. So the power of 10 wasn't supposed to be affected. For some reason, it was affected right here when you should have just did 8.4 times 2. And then you keep the power of 10, 10 to the power of 3. All right? All right, so here is the rule that you need to copy, okay? 8th grade is all about rules. 8th grade and beyond is all about remembering rules and plugging in numbers, okay? So please copy this. Pause the video and copy it. All right, so hopefully you copied it into your notebooks. The rule. Remember when we see numbers, when we see letters, they're variables, they represent numbers, okay? So A times 10 to the power of m times b times 10 to the power of n. When you see something like this, do you notice how m and n are two different letters? So it's okay if the exponents are different, okay? So what do you do with the numbers without exponents? You multiply them, okay? And then you put the power of tens together like this. And remember what this rule means? The very first rule we did, we add the exponents. So the numbers without exponents, you multiply it. And then you keep your power of 10 and you just add the exponents. That's it. And we'll see some examples of that in a minute. Okay? So the only difference is that we add the two numbers that do not have an exponent. We keep the base 10, not exponent 10, and we add the exponents. Okay? We'll do examples in a minute. Here's something else to add to your notes. Okay? Give you a second to pause and copy it. Hopefully you copy this into your notebook. Okay, when we're dividing scientific notations, we separate it, just like how we separated it here. Okay, we're going to separate it here. A over B times the base tens, and then we have an M and an N. Again, they can be different. That's totally fine. We can either divide this or we can keep it the way it is, depending on the situation. Since we're using calculators in 8th grade, it would probably be easier to divide it. Times, we know this rule. When we divide exponents, you're really just subtracting the exponents. Remember, you do the numerator, subtract the denominator. Always in that order. Okay, if you do n minus m, then your answer will be incorrect. All right, so if you are able to just use the formula, that's perfect, okay? But what if we're given some word problems, okay? Here is an example. How many humans do you think there are for each cat in the world? Large numbers like populations are often estimated using scientific notation. So we use this in the real world. Whenever a number is too large, we like to put it in this form, okay? Remember, base tens, all it really means is that you're adding 9 more zeros. Remember that, okay? And then this is the beginning of the number, 7.5, and then 9 zeros after that, okay? So there are an estimated 7.5 times 10 to the power of 9 humans and 6 times 10 to the power of 8 cats in the world. So we want to divide that number. We want to see how many humans do you think there are for each cat. So when we see that word each, how many of one thing for each of something else, that means division, okay? And what was the first thing we saw? Humans. How much is humans? This number. So that's why it's on top. What was the second thing? Cat. Okay, well, how much was cats? This number. So that's why it was at the bottom. And do you see how we separated the numbers? And then we put the two tens together. And this rule means that we're subtracting the exponents. 9 minus 8, not 8 minus 9. It will give you a different answer. It'll be -1 instead of just regular 1. So here was the answer. They divided 7.5 divided by 6. And here, I'll show my calculator. 7.5 divided by 6 equals 1.25. And then 9 minus 8 is 1. So remember, 10 to the power of 1 is just 110, right? So all you had to do was move the decimal place one time, and we'll talk about that later. So there are roughly 12.5 humans for each cat. Okay, I think the main point I want you to understand is that when you see a word problem worded like this, you need to know that, hey, I need to divide. And your cool down will have to do with something like this. Hint, hint. All right, we're gonna skip this one because I didn't understand where they got that number from. Okay, so which creature is the least massive? And if you look over here, here are a whole bunch of creatures. Here's the number that they represent, and here's the mass of one individual. Okay, so we want to focus on which creature is the least massive. Estimate how many times more massive a human is compared to a bacteria. Okay, 6.2 times 10 over 1. 10 to the power of 1. Which one do you think is that being represented by? Oh, the human, right? Because what did it say first? The human. And then what's at the bottom? 1 times 10 to the power of -12. What do you think that is? Oh, if you go down here, bacteria. So remember, you separated. You do this rule. 6.2 divided by 1 is just 6.2. Okay, 1 take away -12. We don't assume that this is the operation that we're doing for the rule. You need to put it there. Okay, don't get confused. And then how do I do that in my calculator? 1 minus 12, and then with the negative equals 13. 13. Okay, so a human is about 60 trillion times more massive. 13 zeros is about a trillion. Okay, or this answer is just good enough too. All right, let's see if we do some more. We're not doing those. Those are too complicated. I don't want to confuse you. Here are some more examples. So just take a look at that. Maybe add this to your notes if you need to. Remember, when you're multiplying, it's 5 times 1.5, and then 10 plus 2, which is 10 to the power of 12, and then 7.5. Let me show you how they got 7.5. 1.5 times 5. 1.5 times 5. 7.5. So remember, the parentheses means multiply, so I'm going to multiply those. And then what does it mean for my exponent rules? I add the exponent, and I keep the base. Division. I'm going to divide the whole numbers. And then what is my rule for dividing exponents? I subtract it. And here it is right here. Same here. Multiply 5 times 4. And then so on. All right. Don't focus on this one. This one is incorrect. Should have been 5 times 4, which is 20. Yeah, they're missing a 0. I didn't create this, guys. But all right, so now you're ready. You can either look at the YouTube video if you're still confused, do some practice problems, and then you're cool down. All right.